can see that well enough. All right. So today, we don't have to do introductions because we all know each other here. So I was going to go over some advantages. We're talking about advantages for Go. And that was our agenda. So I got requests about how to package functions, so I'm going to go over that. I'm going to do some basics and do some show you how to do client-side web development using Go. Yes.
Good news, I did actually make my first package and include it in one of my other projects.
It's not that bad, is it?
Help from the slackers.
Well, there you go. Not too bad. So I'm going to go over, interfaces and types.
Yeah, that will help me a lot.
Okay. So, and this web development deployment automation, I'm going to go over Kick, it's called. I'm sure there are many, but. So we're going over some reasons why we should use Go as opposed to other languages. And the architects, are well known, and that's one of the biggest arguments. Ken Thompson, Rob Pike, and Rob Grismer. And so for system advantages, highly performant concurrency. We've been over concurrency here. That you can run concurrent Go routines. Kubernetes and Docker are written in Go, and it's script-like, and it's when you write it, but it's a compiled language. And the only thing you port to your system is, your static files, pages, and your one bit of code. Easy to containerize that way. So, clean syntax. All right, so the idiomatic nature of Go and the way it's written, the colons, for example, practical things like that are inserted at compile time. So it does have a standard library, and we were talking about how that's all compiled. You don't need to have a Go library on your target system. Inherent garbage collection, that's a big thing I would say over like C++, right? Garbage collection is a big problem, like phantom memory thieves and bogus memory leaking, something like, and they call it many different things. But so this is also some resources. I don't know if anyone's ever seen this presentation before, but I try to keep these resources in here. This is our Slack channel, the Go docs, which you can run locally as well. And I'm going to show you how to do that too, if you don't know. And some training, which I go to Udemy all the time. Udemy's great. Did you ever check that out? It's great. You can learn anything you want there. All right, so let's get into all of that. The one I'm going to use tonight is my Kickstart. So if you guys want, I'll share this link. Would you want me to share this link?
Please.
Okay. There you go. And let me put that also on this is the Downingtown Gophers Slack, if you guys haven't joined it. That's a good one. It's a Gopher, it's a Golang channel. And if you want to know how to do it, how to join it, go on the meetup, and I have a video that shows you how to join this, okay? You don't have to do it tonight, but anyway, it's there. So I'm going to talk about a type. So when you declare a type, you use the keyword type, and then you name the type, and then you use the keyword struct, and then field type, field 1, type 1. They could be the same type, but it could be a different type as well. Any combination of types can be used. So when you have a constructor for that type, you'd say it's a function, and you know, in general, you'd call it new, and then type name. Okay? And then this portion is a receiver. What that does is it takes all of the values that are related to that struct, and it populates them with whatever whatever methods you use. Okay? Now, and then, so this is the type name. You declare it as, you know, returning a pointer to, you know, something saved in memory with the values populated. All right. So the interface, when you declare an interface, and this is going to be a little bit more clear in a minute. So in other words, you might have a method, right?
Question.
Yeah.
Is the constructor, is there any difference between like Java constructor and this constructor?
I'm not, well, it's a little bit different in that this is an instance of that type. And it includes any methods that are named that are associated with that type if they implement the interface. And I'll explain that, okay? So you have an interface, right? And it's of type interface, right? That's the key word there. Type and of type interface. And then you give it an interface name.
So these are default type and interface, those are default keywords?
Yes. Well, yes, interface is, and you know, type is obviously. Yeah. This is the name you give. All right, and it's, okay. And I'll give you an example of this so you could see it. These are the rules, the syntax, right? So that then you have a method and a return object, you know, whatever is returned, the signature basically, for that interface. So you got a method name and what it returns, you know, and then there's two here. So method 2, type 2. All right, so just to lay it out a little bit differently, declaring a type. So field 1, type field 1. It's a little bit more clear that way. That's your struct, right? And when you create an instance of the type, all right, you will set something equal to the name of that type, right? And the values are populated. Then you create an instance using the field names and populate them with the values. Now this is, if you do it without the field names, the order does matter. In other words, it'll be in order of the way things are declared in the struct. So say you have an array. If you have an array of values, right? The first value will populate this, the second value will populate this, etc. But if you want to not disregard order, you name the fields. Simple as that. All right, now, it's clear as mud now, but I'll give you an example. And this is when I can hopefully...
Question. Lowercase versus capital for the variables, since it's all going to be in the same file.
Okay, capital has a special meaning. When the first letter of your name is capitalized, it's exported.
Right, so when you create.
That's the export statement. It's the capital letter.
Yes, my question then is, once you have built your structure, inside the type definition where you have your variables, when you go in another package to create an instance, do you have access to them if they're lowercase?
No,
Okay.
not unless you're in the same package.
Okay.
If you're in a different package, you don't have access to them. That's how things are scoped. We'll
Okay.
talk about scope.
So if you want it outside the package, you got
Yeah.
to capitalize
Yes, yes. Scope. You have global scope. You have etc. Right. There's all different scopes. But the nice thing about Go is that you can use a variable any number of times in any number of functions, as long as the scope of it is within that function. It's not kept. So
if I want to, if I want to save any value, and that's I'm going to use different functions.
you make it a global variable. Yeah. All right. So
What would be the life for that global variable?
what?
What would be the life?
The life is in the scope of where it's used. Say you have a package, a Go routine that's using it. As long as that Go routine is alive, it's not closed out.
Okay.
Yeah. And if something's in an argument, if it's in something that's shared, we'll talk about scope. In fact, I'll make that another topic. All right, would that be good? All right. Okay, so let's go over an example. I have it in high contrast because my eyes are terrible.
Yeah, that's actually great.
I know. Okay. Okay, so here I've declared my struct. This is just an example. Field 1 type, field 2 type, and this is the constructor of new, all right? And so let's look at that in the shape demo. Just keep those things in mind. Okay. This is our main program. So everything's relative to this, right? And I've included this simple shape, which is here. This is my package. The rules are for, Go, idiomatic Go, is that a package needs to be in a folder with the name of the package, lowercase, and then the files in it have to be in that package, declared with the package declaration. So it's looking at this location, and then, main, you can have multiple main in the main package too, right? But they would all be in this shape demo. So this is saying, now let's see what a shape is. So R is what? A rectangle. It's of type simple shape. It's in the package simple shape, and that's a rectangle. So these are all shapes, right? So what do they have in common? That's what when you define, something that they have in common, that would be where you'd consider what your interface should be. So simple shape, that's going to be the main definition of what's a shape. A shape has an area, and so anything that has an area with if it can be used in this area function and return a float, that's a shape. Okay, so now I have this function. This is my shape function, and all it's going to do is it's going to have this variable s of type shape, and it's going to return a float. So it's going to return a value that represents that area, right? So it's going to return s, which is the area of that shape, right? So now what's that area? So now something needs to implement this function and return a float. So let's go into the simplest one, which would be a rectangle, I think. That's, maybe it's just me. So a rectangle has height and width, right? And the thing that we're seeing about this is that new rectangle returns a pointer to this type of rectangle. All right? And this function is a method that implements that interface. Because what does it do? It has the area function, uses the area function and returns a float, right? So we have a new rectangle, and we're going to say the area function for a rectangle is width times height, right? And it returns a float. So there's my area function, and it returns a float. So that's, now I've implemented the interface, right? With that type. Now I can go out, I could do this forever. I can have as many types of shapes as I want, as long as they have that area function and they return a float. So basically, it's, that signature. There are multiple types of signatures, and they can be very complicated. But as long as you meet those rules, then you've implemented that interface. And then you can use any of the methods that are associated with that interface. Okay? So this is my package simple shape, and all these are in the same one. So the circle. So a circle, this is, as you recognize this now.
Can you explain that function, please?
Which one?
That function, circle, area?
Yes. The value pi times radius squared.
You declare the function then.
Okay, yes.
Yeah,
Okay. This is the way we populate those values, okay? Something's going to call this. So a new circle. So, I'm going to have a variable, and it's going to say like C equals this. All right, this is my circle. It equals this, right? And then I'm going to get the area of that circle. So the methods associated will be available once I implement, once I, set my variable equal to this, right? And I can use all these I can use this method. What?
My aha moment was realizing that you're calling that area function on a circle object.
Yes.
So the new circle, you're not. The new circle is
Right.
just a function that any program calls
Right.
to get a reference to the circle. Now I
Yeah.
have a circle.
You're populating the
And
values.
now I can run circle.area.
Right. You're populating those values. And then you're running a method on those
Yep.
values, right? So here, let's go back, because let's follow it through. Now we can trace it through, right? A circle, see, what is a circle? It's a simple shape, and we're going to make a new one. And here's my values. I have the radius and pi. I just did it that way so we could make it really clear. I could have put pi in here. You could do that easily. You could just make this a value. You could, because pi is never going to change, it's a constant. So you could put a constant here and say, yeah, that's part of my method, and that's probably what you would do. But I don't know. I kind of did it that way, just because, no reason. So let's do that. Let's run it. So what's it going to do? It's going to print all these things. It's going to say the area of my rectangle is what? It's simple shape dot simple shade area. See, it's calling that method, right? On that value, which is this. Get it? See? So now I've created a variable that's holding those values. It's holding these values, right? And this knows how to use them because it's a method that uses those values. So now we'll run it. Relative path. I'm just going to paste it here real quick. This is what I need to do. I know exactly what I need to do. Copy this. All right, that's it. So now when I run it, I have to be able to run it. Oh, maybe it might have been something else, but so that's the only import, I think. Yeah, that's the only import. I should be fine now. Terminal. Okay, go run shape. Go. Yeah. Sorry about that. I moved that from the root directory. I forgot about that. So everything's always relative to your go path, which is, go path is like a variable you set up in your environment. I'll explain that to you sometime too. So now we have, that's obvious, right? Area of my rectangle is 9. Triangle would be half of 9, right? And this is, we're just going to believe in this because I could do the math, but. So, is that kind of clear or? Okay. All right, so what time is it? 6:30, we have plenty of time. All right, so now that we've done that, I'm going to go into the next thing on the agenda, which is the first thing I want to move some stuff around in an existing package so I can show print how I would divide up a package. You might want to know this too, Nazrul, I don't know. So this is a web app that I've been working on and calling it Kickstart because I'm demoing how to do Kickstart. I'm going to throw this terminal away from that one so I don't get confused where I am. So in this, I'm gonna run it first, just so you could see something that's going on. Let me make sure I don't have my automation running, because I might. I have another terminal here. I think I closed it. No, I didn't. I didn't close it, but it's not running. Okay, that's good. So I'm gonna run it locally, just to start out with, as I think the end game is sometimes the best place to start. So I'm going to go run my main program, which is Kickstart. This is not Kickstart. I just named it Kickstart. This is the normal way you would run something. I've already done a few things that I'll talk to you about in a minute, but so it's running. And what that is, once it runs, that's all I have to do is say run that. Now it's not compiled yet, but it will be in a minute. So that is, already I have it up here. That's this. Okay. Now I'm going to stop it just so you see that that's it, because I just refreshed it. So okay, see, I just stopped the server. I'm just going to start it up again. All right. Here we are. Now this is some dynamic, a dynamic way of writing to a template, all right? And I'm showing this to you for a particular reason. Now if I do this, right, and I write guest name is equal to, I did this before, so it'll change, right? So I could name it anything, Pranay. Right. All right. So now I'm writing something to a HTML template. That's what's happening. And what I'll show you where that is, but it's not really to show you how to write the templates yet, but I will be doing that in a second. But there's I'll do a little bit of that, but my main thing right now is to tell you this particular thing I'm doing is handled a little bit differently from the rest of my program, and I put it in here just for demonstration purposes. So if you look at this, I'm using what's called the Gorilla Mux. I'm not going to go into depth into this, but you'll see. You know what routes are in program? You might know or you might not. Say you have an endpoint, right? You have a host, you have a URL, right? So this is going to be the very last part of it. It's an endpoint, right? So once the server sees that endpoint, it's going to do something, right? This is my handler. What am I going to do once I see that? Okay, I'm getting a request from the client. It has this endpoint, so now I got to do something. Well, if you look at all this, this is our R dot. Remember we talked about types. Here's my R. It's a new router. All right, that router is a Gorilla Mux router. See that Mux package? So I've imported, now you know what that means, right? I've imported this. This is my Mux router. It's a Gorilla Mux router, it has a lot of security features, etc. Now, I'm using that throughout this, but in this one particular case, I'm not, right? I did that guest handler so that you could see it in a very primitive state. This is just a default HTTP handler, no third-party packages. This is Go. I have TLS set up on the listener, listen and serve. See, so I'm using HTTPS. So there's a way to do that. So you got your certs in there, you got all that. So that's TLS. But I mean, I'll go into that some other time. But I want to show you what the handler looks like. That's why I did this, because I wanted you to see a handler in its raw form. All right, so a very primitive handler has that hello guest handler, and its signature, this is just the HTTP package that comes with Go. And it has included a method called response writer. Now I'm naming that W here. And in Go, idiomatic Go, you just name the simplest names you possibly can. If it's a local variable, just give it a W. It means writer. R is my request. What's that? It's a pointer to whatever the client is sending me, right, on that port. So this is R. R is a variable. R is a location in memory, right? Think about this. R is a bit of memory. What is in that memory? Everything the client just sent me is in that memory. Because the server is listening on a port, and everything that client sent me is in R. Okay? Now you know. So you're going to get the full URL that the client sent. All right. And what's going to happen? I have a variable I named. It's a string. It's called guest name. You saw that up in the URL, right? Guest name is going to be part of, I'm going to get that where? From R. From R, I'm going to get a URL. And it's going to have a query. Okay? R, so what? From R, I got a URL, and it has a query, and the method is get, and what am I looking for? Guest name. There you go. Is that clear? All right. If guest name is blank, it's going to be Jane. You saw that in the beginning, right? So guest is equal to guest. Now this is where I'm kind of setting up my template. So guest is a variable I'm declaring. It's equal to this type guest. And I'll show you that. Actually, you could do this very easily. Go like this. Go to definition. If it doesn't take forever, there it is. There's my struct. All it is a name. There it is, defined, right? I'm going to go back. How do I do that? Control minus. Very easy. All right. And then I'm going to do what? All right, so now I said guest is just that name. It's a string. It's a name. It's a string. Okay, now I'm going to populate that name. How? I'm going to render a template, the template, with this guest. Okay, I've populated it with this variable called guest name, which is now whatever you want it to be. Okay, that's easy. Now, and that's it. So now I'm going to call render template, and I'm going to pass to it a writer, and I'm going to pass that variable guest, and templates. Oh, I'm going to call this file, and I'm going to populate that template. I'm going to tell it what template to populate. So I'm passing arguments. A writer. I'm passing this writer up here. This writer, which is a response writer. So the render template function wants a location. You know, what's my template you want me to write to, right? What do you want me to write in it? Here it is. How do I do it? This is how. Your way of writing. So render template does what? This is its signature, which we already just went over. So, and now it's just simply going to, T is parsing a template file. It's looking at the template file, and it's going to look for a variable, for that name. I'll show you that too. Let's see. It's in my templates, greeting. See this? Name. That's how that matches up. See? This is a little notation that says, put the data here. And what data? Name. Okay? Cool, right?
What template package is this? Is that
This is just HTML. It's the Go template. It's the templates.
Oh.
HTML.
In
HTML.
the previous file you had template dot render.
Yep. Let me show you that. Sorry, I skipped by that.
I was wondering
Shouldn't do
what
it.
package
Template is
is.
HTML template,
Oh,
which is
really?
up here. Yep. Here's my import. HTML. You have to use HTML. There's a text template, and you could use it, and it would work, but it doesn't protect you from cross-site scripting, and HTML does.
Right.
So, yeah, HTML totally protects you from cross-site scripting. So it doesn't allow them to put in anything you didn't declare. All right. Text, you could do anything. So let's see. So what else did I was wrong? Okay, this is just an error. You basically see this error in your standard out on wherever you're running it from. Okay, now you've seen this. So what should we do? We could take all this stuff and put that in a package. Do you want to do that? Are you up to it? All right, so let's do that. So we have handlers up here. We have a whole bunch of handlers right here. A whole bunch of stuff. So I'm just going to make a new one. Greeting.go. And this is in package handlers, right? I'm just going to say greetings. New file. Greeting.go. Package. Handlers. Yep, thank you very much. There, very easy. All right, so now I'm going to go back to that other file and see what can I take out of here. All right, so instead of, I'm going to get myself all prepared. So instead of doing this, greeting, where's my greeting? Here it is. Instead of doing this, I'm going to say, handler.handle func. Now all I have to do, I'm going to take all this stuff. But I have to change this. But I will, and I will. But let's do it this way. So I'm going to take this, and it's here. I'm just going to move this. It's going to have to be changed. So what am I going to call? Hello guest handler, right? That's my method. So, did that actually, okay. So I don't have to export this one. This one can be local, because what's calling that? Render template. This is calling it. It's local in the package, so I don't have to capitalize that one. All I'm going to do is capitalize this one, because this is my handler. All right. So now all I have to do is go back here, and hopefully, if this works, I'll do handler. No, so this is wrong. Handle func is the normal handle func. So handle. Did I remember that right? Let me copy this. I'm just going to do this. Oh, that's my problem. Sorry.
Documentation.
No, I forgot the HTTP. What's that? It's like HTTP. There. Now I'm good. Why didn't I get an error though? That bothers me. I should have had an error on that one. So now I should be good. Let's see. Oh, it's running. Yay. So now do you get it?
I do.
I know you got it before this, but it's actually pretty easy, right? I mean, so now, there you go. Let me just change this name, see if we can, there we go. And that's how it's done. All right, so that's that. Now we did that. All right. So let's go over some other things. Let's do the next thing on the agenda, which was kick. So you see how I had to, you kind of saw something there. What you saw was me having to restart, I had to, if I had this running as an app, I would have done this. I would have said I'm gonna go. I still don't have the path thing down instinctively, but go. So it's built. It's built. So now I've built Kickstart. Now I can run it from here. All right. So now I've compiled Kickstart, and I could actually move that to my bin folder. And why it didn't do that, I don't know. Oh, I think I know why. Let me do this. Go install. Let me copy the relative path. Okay. That should be it. Yay. So it built it. Now I can run that anywhere. So I can go here, but you want to run, since it's a web app, you have to run it where your templates are, or it won't know how to find them. So I'm going to go, CD. Okay. So anyway, this, if I run it here, I'm going to just run Kickstart. So it's in my bin folder now. When you install it, it goes in your bin folder. You can run it from anywhere, but it needs its HTML templates relative to where you run it from. That's something to keep in mind. You always run the app relative to where your root is for your project, and then it knows how to find everything. So I learned that by many pains, from many pains of this kind of thing, doing this. So now I have the whole thing running. Now this is not the project actually. The project has a login, hopefully, if I can spell. There, and I have a database running. Let me just do this, Docker, yes. I have these two databases running. This is a client and a MySQL server and a Docker container, and that's what's doing my authentication. So when we go back here, we'll get all the errors and such that are related. I'm going to make this bigger, to the program. So you see all the calls from the browser, right? They're all named there. So now I'm gonna log in. Should work. So that's doing that because feed isn't developed yet. I haven't developed feed yet. I have other things developed, but it automatically reroutes you to feed, which is going to be like a very basic page. I have this one done. Yeah. I have a couple pages done. Let's see what else. There's a sign up. There's a bunch of things. I don't remember all the different ones. So, okay. So that's a lot of problems. What I just went through, like every time I make a change, right? Now I want to do like a simple thing, like a change to the template. I want to change like the header, some of the common things. I want to make a new name. I'm going to go to the header, and I want to just make some simple change. Let's call it Kickstart. Well, that's not going to show up. Serving is set in stone once you run that server. Right, so what Kickstart does, I'm going to shut this one down, And I'm going to run Kickstart so you can see that I can make any change I want. This is what you run. You run this line right here, and I have this all on the GitHub, which I will show you. GitHub, I have like a procedure, which is right here. So it basically goes through the steps to set it up and, you know, set up the server and all that. And then I have another README on Kickstart, how to set up Kickstart. All right, so I'm showing you the steps that you would have to do to deploy. This is part of it. So what you do is you set up some environment variables, which is basically the root of your app, right? And then if you want Gopher.js to run automatically, you set up a variable for where your Gopher client is, where your client is, right? Because all the JavaScript is in there. So that's pretty simple. Then you run this command that tells Kick, you know, this shows you how to get Kick. And isomorphic Go is it's the Gopher.js and this Kick thing. They have both tools. So that's the command you run, right? So it's all on that GitHub thing if you ever want it. Now I'm going to run it. So far so good. Now let's look at it. It's gonna have that change, I think. Should have looked at the title. That was the title I changed.
Is that Gorilla Mux putting that log out to the console?
Yeah. Oh, look, Kickstarter. It's the title. So now it'll change. There, see? Now that's all I have to do. Every time you make any change, it'll restart this. So let me make let me change it back now.